record and open up preview, maximize. Okay. Well, hello everybody. Welcome to our third data science education webinar. This webinar is being made available through the Concord Consortium, a nonprofit educational technology laboratory based in Concord, Massachusetts, and Emeryville, California. We started these webinars because last February we convened over 100 thought leaders from organizations around the US and 6 continents in Berkeley, California to lay out the first steps in data science education. We are working to continue that momentum through our webinar series, and we're very passionate about the next steps in this revolution. You can learn more at our website, codapp.concord.org or concord.org/meetup. I'd like to introduce you to today's facilitator, Rob Gould of UCLA. Hello, Rob. Rob is on the faculty of the Department of Statistics and the director of the Center for Teaching Statistics. And in this webinar, we're going to explore the interaction between habits of mind and data moves, particularly so that we can understand if this construct is useful for thinking about curriculum. A recorded version of this webinar will be available on YouTube, and we'll email you details about it through Eventbrite after the fact. If you are comfortable sharing your name and face, please do turn on your web camera during the webinar so that we can see you. This is meant to be a participatory by design webinar. I'd also like to, what that means is that we will work together to decide on the conversations, the connections, the activities we want to discuss. We'll be facilitating the live questions that you have, and I'll also be the text-based question on Zoom chat or Google Docs. And Rob will explain what that means in just a few seconds. For those of you just joining us, welcome to our webinar. Our speaker is Rob Gould, who will be speaking about and data moves. Rob, I'll let you take it from here.
All right, thank you. I'm really excited about this. Let me share my screen and figure out how to do this. I think I do it like this. All right. Am I showing people a slide with the title, or are you seeing me? Okay, good. I'm glad you're not seeing me. So welcome. Thank you very much for joining us. This is kind of an experiment for me. So in the tradition of the Concord and DSET webinars, I don't have, this isn't one of those webinars where I'm going to tell you something that you may or may not know and you're going to learn something new. This is one of those where I'm going to share some thoughts that I really don't have a great handle on right now, and I hope we all join in together and come up with a better grasp of what's going on. I have planned about 15 to 20 minutes of just background, and then I'm going to stop talking and we're going to play games. But basically, to play these games, you're going to need some statistical software, which you might want to open up now to be ready. And somewhere, Natalia will tell us, I have these links to some websites that we're going to need to use when we get to those activities. So I want to just start by saying where I'm coming from with this and the background that got me into thinking about this topic, and then a little bit about why I think we need to start thinking about computational thinking. I'm a statistician, and so my approach has always been to think about what is statistical thinking. And so this whole notion is something. So in any case, with that in mind, let's go ahead and get started. I wanted to start. My introduction to all this came from my participation in the Mobilize project. This is an NSF-funded project. We're now entering our 8th year. I joined in year 2 as the principal investigator. I came in late. It's basically, the goal of this project is, roughly speaking, to integrate computational thinking in K through 12, well, in high school STEM courses, and in particular, computational thinking with data. And so this was originated by a colleague of mine in computer science who invented a paradigm called participatory sensing. And the aspect of this that applied to mobilizing was that students would use their cell phones or their mobile devices to collect and then analyze data. So this project began with creating modules that were 3 or 4 weeks long for algebra and biology courses. Here's kind of I'm not going to spend time reading this whole thing, but as far as the general objectives go, the notion was that students would be able to collect their own data and therefore have opportunities to make unique discoveries, and that they would kind of control which data they collected after some introduction. And the goal wasn't just to teach them to analyze data, but to open up this whole notion of a world of data and help them understand how professionals use data, help them understand how data interacts and intersects with their life, and give them some fundamental tools to kind of take control of that data themselves. As you may not be surprised to know, this turned out to be extraordinarily ambitious for a 3 to 4 week module in an algebra class and in a biology class. It was just a lot to learn, and we also found that if we tried to extend the modules any, it cut into the standards and the curriculum that they had to teach. So with that in mind, we came up with this course, the Introduction to Data Science, which was a year-long course. So the idea being that if that was a lot of material to teach in 3 or 4 weeks, then a year should be enough. Turns out it's not, but it should be enough. So I just want to give you a little overhead of that so you know where we're coming from. So this Introduction to Data Science curriculum requires Algebra 1. Its guiding principles are the Common Core math standards and practices, with an emphasis on what they had to say about modeling. So the Common Core math practices are rather silent on computational thinking, and they have something to say about data analysis. If you go later and look at our curriculum, you will see kind of a strong emphasis on some math and probability that we were required to do more or less to meet the standards. But the other guiding principle was the GAZE document, the K through 12, particularly the beginning and intermediate levels. And I have a little bit more to say about that in just a moment. But basically, these are the levels where students are this is here to kind of remind us that we're making no assumptions that they have any knowledge about statistics or data analysis. And also to remind us that we're not trying to teach inference, where this course is not intended to replace a statistics course or an AP statistics. After much politicking, we were able to get this to be, I put credit in quotes, there's an official term, but essentially students who take this course, it's as if they had, as far as entrance to public schools in California, it's as if they had taken Algebra 2. So taking this course provides an alternative pathway into colleges in much the same way as other statistics courses do as well, and computer courses also. Our plan is that after taking this course, students could then take AP statistics. They were hoping that this will help develop computational strands within the high school curriculum. So a student would take Algebra 1, and then they could take our Introduction to Data Science, and maybe at the same time or the next year they would take a computer science course, and then they would follow it up with an AP Stats course or an AP Computer Science course or something along those lines. So that's kind of how our Introduction to Data Science course fits into this curriculum. I should also add, before I show you the content, this was truly a partnership with the Los Angeles Unified School District. So this was not an example of us sitting down and thinking what would be the ideal data science curriculum. This was us working with groups of teachers and administrators and saying, what would work in your classrooms? What could we do that would be sellable to the teachers, sellable to the students, and doable within the construct of the district? So one of the key features is that the students learn R. They work using through R Studio and using something called the Mobilize R package. So the Mobilizer package is based on something called the Mosaic package by Randall Prime and Nick Horton and Danny Kaplan. Both packages essentially try to create a unified syntax. The R syntax can be a little bit baroque, I guess, if you're seeing it for the first time, and especially if you're a new learner. So what we try to do is simplify that. Well, simplify is not the right word. Uniform, make it much more uniform as much as possible so that students had less to worry about. It also includes what we call wrapper functions. So actions that may take several steps are kind of wrapped up in a single function so that students just make that one call. The curriculum itself has 4 units. The first unit is roughly about interpreting data, what data are and how to use them and manipulate them. There's another unit on making inferences. This is done at what's now called the kind of informal statistical inference level. They're not learning about p-values. They're learning about, through randomization-based inference, they're learning how to simulate null distributions. They're learning to understand what it means to say something happens by chance. And they're learning to make kind of subjective and informal comparisons of their actual outcomes with this conjectured chance-based outcome. There's an entire unit on probability as the standards now require. What we've added to this or changed is that it's very strongly simulations-based, again, using RStudio. And there's a final unit on multivariate modeling, which is actually a little grand of a term, but I think the interesting things from our point of view is we include multiple regression with an eye towards making predictions. So not about understanding what the parameters mean, but understanding how you might build a prediction model. And there's a lesson or two on CART, this classification and regression trees. So that's the course that kind of spurned all of our thinking. And the way we kind of thought of this course was it would be a blend of computational thinking and statistical thinking. And statistical thinking was something that I, at least, and many of us had a handle on or thought we do. And I'll share you what that handle is. So when we talk about statistical thinking, we are thinking of something like this. We called this the data cycle. But if you're familiar with the GAZE K-12 document, you'll see this as the statistical investigation process. And it, in turn, is based on this PPDAC cycle by Wild and Fancook. And for us, statistical thinking means that a person is engaging in these 4 stages when they're examining data. This cycle seems to suggest there's an order to that, and that's not an important part of thinking. That's more of a guideline for starting out. We're recognizing that people may oscillate between these stages. They may go in a different order, but if a person is kind of employing these 4 sorts of processes, asking questions, examining the data, making an analysis, answering the questions based on the analysis, we consider that to be, for the purposes of this project, statistical thinking. I guess I should also say that this statistical thinking isn't really possible unless you have a background or are sitting on a bed of understanding of basic statistical concepts. So your ability to navigate this cycle depends a lot on your ability to understand this. An example of a concept would be the distribution, the notion that the mean is the center of mass of a distribution. When we started the project in the very first year, we saw what happened when this didn't happen. We made assumptions about what some of the teachers knew, for example. And so we would see them kind of engaging in this data cycle by producing a graph, but then stopping right there because there was no notion of this graph as representing of a distribution. It was seen purely as a kind of computational product. And one of the things we've been doing in our professional developments was really boosting these fundamental statistical concepts so that they could engage in this investigative cycle more fully. So that's statistical thinking, but computational thinking we have much less of a grasp on. Of course, if you Google computational thinking or use something more sophisticated, you'll find a substantial literature on this. The literature, I think, does not shed too much light. The Computer Science Teachers Association has a document that defines this. I think it's about 30 pages long, and it's a laundry list of topics. So it's a broad area. People aren't quite sure precisely what it means. But I think we don't need to know too much more if we focus our attention more on what is computational thinking when it comes into contact with data. So what we really want to know is, what does it mean? What parts of computational thinking do we need to borrow and understand to help our students analyze data? So if that's what we're thinking about, then I think it would include everything we talk about when we talk about statistical thinking, plus some more. And when you ask people what the more is, you'll hear things like, well, it's analytical thinking or it's algorithmic thinking. Well, analytical thinking is something every discipline claims as its own, and justifiably. So that's rather vague. And even algorithmic thinking, I've not gained a whole lot of traction on what that does and how that helps us analyze data. So this is kind of represents my state of confusion at the moment right now. And I had some light shown in the last couple of years by the people on this slide. Bill introduced to me this notion of data habits of mind, which I took to be as kind of reflexes that we might want to have instilled in people. So for example, I've put a whole bunch of them up here, but if a question arises, to have the reflex of thinking, I bet there's some data out there, or I want to find some data that would help me answer it. Or if someone else makes a claim, a reflex response of, where's the data that supports that claim? So those are examples of data habits of mind. And then a little more recently, Tim Erickson has been talking about data moves. And he says, and he has a webinar about this. If you haven't seen it, you can go back and see. He mentions data moves as verbs, or they're things you do to data. But in particular, he thinks that these separate out data science from statistics. Here are some examples. These aren't his. These are ones that that we came up with thinking about our project. But one data move is to upload data into statistical software, for example, or to organize a data file, or to scrape data from the web. Hadley Wickham, in his package dplyr, has another set of data moves. He has like 6 verbs, which get you quite a long distance towards cleaning data, organizing data, arranging data, and even analyzing data. So these notions of a habits of mind and a moves, I thought, might be a nice way of getting my hands dirty and getting into the soil about what computational thinking looks like when it's applied to data. I think one thing, though, that's missing again is this notion of understanding fundamental concepts. So that blue ball in the middle is my attempt to recognize, using dplyr language, computational thinking applied to data. And in my way of thinking, what moves us back and forth between our habits of mind and our data moves, a bridge, if you will, are these is our computational thinking. So our ability to think computationally in the context of data should help us kick those habits of mind into place, and should let us know which data moves we employ to act out those habits. This computational thinking sits on a chair of concepts, conceptual knowledge. This is, by the way, as far as I could push the new keynote icon sort of thing to create a metaphor. So there won't be any more of this. But this is this notion that somehow there are some underlying concepts there. I'm pretty convinced that anything you could put into statistical thinking sits on that chair. But there's a whole other group of computational concepts that are needed to first to instill these habits, and then to employ them in actual actions in these data moves. So our goal for today, as an ambitious goal, is to try and make these connections explicit And in just a few moments, I've got some activities that we're going to engage in. And we're going to spend most of our time doing these activities. I just want to add one other interesting thing about why we should talk about computational thinking at all. In preparing for this talk, I was rereading the Gaze guidelines, and they have a nice set of appendices that illustrate engagement in the statistical investigation cycle, the statistical thinking. And here's a screenshot of one of the pages. This is an investigation in which a student wonders if standing up for a few minutes increases your pulse rate. And to do this study, the student recruits 15 other students and randomly assigns them to two groups. And the only difference is one group sits down first and then stands up, measuring their pulse rate before and after, and the other group does it in the other order. So there's the category there is kind of so that's how the randomization happens. I don't think you see that in this data set, but what's interesting is you see two data sets in there, and the only thing this document says in respect to the analysis of these data is the data arranged by treatment are in table 24, and the matched pairs data are in table 25. So as many of us know, moving from table 24 to table 25 is by no means a trivial process. And as Cliff's and Bill have showed us in a paper I'm just about to cite to lead into our activity, our first activity, even creating table 24 is by no means obvious. It's by no means clear that that's something a student will naturally create when creating this data set. So, so the Gaze documents have given us a good definition of statistical thinking, but it really glosses over what may be some really fundamental and challenging skills by simply just claiming that here they are, the problem is done. And so it's those little gaps, I think, dealing with data that we really need to think about filling in. So Cliff and Bill, you can both correct me if I've got anything wrong here, but this first activity we're going to engage in was inspired by this paper presented at SRTL, which I understand is coming out in Surge in a couple of months. Shake your head if I'm wrong. So it's the notion that creating a data set and structuring data is itself an intellectual activity that it involves modeling. Down below, what they did was they presented this diagram that represents cars in a traffic pattern on a highway, and people were asked to structure these data. And from their report, my takeaways were that we really do need a better understanding of how students think about data as an object, not just about how they analyze data, but what they're thinking of those data themselves. And in particular, we need better understandings of how they think about multiple representations. I mean, one surprising thing there was in their study was that students actually find hierarchical data not all that difficult to grasp, but the way they structure it varies quite a bit, and they aren't necessarily going to structure it in a way the computer would like it to be structured. So for our first activity, I have something that's kind of based on this idea. So that bit.ly address there takes you to a Padlet. I am new to Padlets, as you may be as well, but these are kind of a play space where we can kind of record our ideas. I'm going to open up the Padlet in just a moment so you can see what we're talking about. But if you can write down that link or something like that so we can go there in a moment. What I want us to do as we're engaging in this activity is to, in the back of your mind, be thinking about what habits of mind were triggered by engaging in this activity. How did you carry out these? What moves did you employ? And what concepts did you have to have as you were doing this?
Rob,
yes.
We also had a question that was posted from a slide earlier. If we could go there before we do the activity. Okay. The question is, what do you mean by data percent is greater than CT percent? I think it was a couple slides ago.
Yeah. So this is a slightly nerdy representation of Hadley-Wickhams dplyr. Now my phone is ringing. His dplyr notation. And basically what that says is you take data, you pipe it. Now I made my phone even louder. Okay, there. You pipe the data into computational thinking. So it's a symbolic representation of the phrase computational thinking applied to data. So just a nerdy little thing.
Gotcha. Thank you.
Yeah, I can't see anyone's comments or anything, but maybe I will once I stop the slideshow. Okay, so
You're going to keep track of them, right?
Yes.
So
let me open up the Padlet here. And so you should be seeing, do you see a screen now with DSET Gould Activity 1 on it?
Yes.
yes.
Yay, good. So what you see in the left-hand corner are 5 people, representations of people. If you hover or you click, you can see a bigger representation of them. And I'm going to ask you this, something very similar to what Cliff and Bill asked in their paper, is to, let's just take 5 minutes or so to record these data in any way that you see fit. And if you could then place these results in this column, one of the easiest ways of doing that is to take a screenshot or something and just drag and drop it directly underneath here, and it should load it up. Or you can double click to create a window that then lets you add things to it if you prefer to go that route. So what I like to see us doing is to take about 5 minutes to do that. And then we'll have this discussion. If you want to, you can go ahead and also add your reflections about your data moves and habits and understandings, or we can, if you don't have time for that, let's just say if you finish early within the 5 minutes, you can start that. Otherwise, we'll add to those things as we start to work. Any questions? Well, let's get going. I have to turn my phone off.
Sorry, I do have a question. What do we record these in?
Oh, anything you want. Yeah, I mean, so
I was looking for a tool in the thing. There's no.
I'm sorry. You need to bring your own tools to the party. So and in a moment we're going to analyze some data. So you need a statistical, whatever your favorite way of entering data in, or and any statistical tools you want.
Use Tinker plots, Cliff.
Oh god. So funny. Sorry, I just spent a lot of time looking for your tool.
How did you come up with these names?
The names on the file?
No, the people.
Oh, the real people.
Oh.
Oh, something was there and it just disappeared.
I was just going to ask whoever put that up to make it comma separated values for me, please.
How did you know, Dan?
Natalia, is there a way that people can indicate that they're done so that we're...
Good question. If you put it in the Zoom chat interface, then that would be helpful for me, just to get an idea.
Okay.
Just write done in the chat.
I aim to please, Rob.
Who is that?
That's Nick.
Ah,
Oh, but we can't copy it.
Yeah, I think you might, yeah. If you you can, no, you can't download.
Oh, if you click expand post in the settings, then it'll work.
it's a good thing there are only 5 of them.
Yes. In real life, there are many more.
Do we have to do all of them or just 2 will suffice?
You're always trying to get out of work.
Well, just once I've done 2.
2 would suffice. Yeah, 2 would suffice. We're not going to actually need the data file. As it is.
Well, Cliff, you know, the missing data raises some interesting questions, and you have to get.
Well, okay.
Thank you, Nicholas.
But that's just my job security for statisticians.
Okay, I'll do 1 missing data.
Well, so I think maybe I can start to wrap this up now. I'll just put down, one thing I thought kind of interesting was, you know, I enter this in a comma delimited file, but then when I open up the file, my computer automatically turns it into an Excel spreadsheet for me, which is kind of interesting, I think.
How do I get my data in there? I forget.
The best way is to just take a screenshot and drag and drop it, or you can open up a window and then these let you add files. So if you want to add it as an attachment.
Oh, I see.
Don't forget to write done in the chat interface if you're finished in Zoom.
Oh, good.
I think we can make this deeper too if we, yeah. Ah, okay.
Oh, that's where it is. It's there. Okay.
So I'm not so sure how well we can have discussions, but I'd like to try since I think there aren't too many of us on this call. But one of the questions I guess I had was that Nicholas brought up was how, well, I guess first I should say we've been doing something like this with our students and with our teachers in professional development. And looking quickly at what you're doing here, we're all kind of coming up with more or less the same sort of thing. Maybe there's some differences in some of the variable names. You know, some of them are locations, for example, which others have labeled sport. That was me, so that's cheating probably. Oh no, some of them have labeled teams or something. Any case, when we do this with teachers, we actually see, in a group of we have about 30 teachers working in 6 or 7 groups, and we'll get maybe 4 completely different representations of these data using different styles. So and
Can you give us an example of a different representation?
Yeah, well, some of them will use a graphical representation, so they won't necessarily go to these tables. These are not, as you've noticed, probably are not necessarily hierarchical, but some of them will still organize them by sport, so there'll be a football column and a soccer column. So there's just differences in the way they do that, and there are big differences in smaller things like whether or not they label the columns, whether or not they include particular columns. So things along those lines. And I'm told, although I haven't myself done this with students get even more creative. So I mean, this is interesting to me because one thing is we have students collecting data. We want them to communicate with a computer. So how do we get that communication facilitated? So that leads us then to thinking about what if any habits of mind you had, or what conceptual understandings do you think people need? And did you employ any data moves in carrying out this organizational process? And in particular, and maybe Nicholas could say something about, what do you think about that missing value? How does that change things? Does that make it easier or harder? What would a student do when they saw a missing value in their data file?
Hi, this is Rick. I'll start off saying good morning to everybody. It's nice to see you all again. As I dove into this task, I was definitely flashing back to interviewing subjects with Cliff's project on how to organize data. And I was also realizing that I've definitely got the tidy data framework in my mind, having read that from Hadley Wickham a few months ago, and the tidyverse. And so as I was creating my table, I was thinking, is this tidy? Is each row a different observation, and is each column an attribute, that sort of thing.
So is each column an attribute? Where would you call that like a conceptual understanding, or does that fit into this paradigm here of?
Yeah, I think so. I mean, there's I'm sure there's other ways to arrange it, like you said, that are more creative. That wouldn't be the case. But it felt like this particular data sort of lent itself to naturally creating a table that was tidy in that sense, where each row was a person, which is sort of the observational unit or case, as Bill and Cliff always called it, and the columns are related to that person, and the cells have a value in it.
So I just want to follow up with that, Rick, that I think that saying that it naturally leads to that is also because of our experiences of thinking about data in as far as cases and attributes. And that if a kid doesn't have that experience, they might not have created anything that looked like what we all did. And
yeah.
So I think, Rob, that I think this is a good task to give us, because it forces us to kind of think about, well, this might be where we want students to go, but how do we get them there?
Right, so the way I'm representing that is, here's our data habit. Our habit of mind is we want them to think, I should make a tidy table.
Mm-hmm.
And now I think we have some conceptual understandings that we might need to employ that. I don't know if there's more missing. Then what moves did we actually have to do to carry that out?
Well, I don't know if this is a move, but taking an object like one of those cards and turning it into data, that's a fundamental process that we do over and over again. And deciding what about that object we're going to record. Are those data moves?
That's a great question.
So I did not record the number of eyes.
Right, and so Bill, that's one of the things that I first started thinking about whenever I was looking at these cards of what characteristics about these different cards do I think are interesting that I should be attending to. And so you're right. I didn't do anything about related to gender. I didn't do anything related to eyes or arms or legs. So it was like, what seems to be non-interesting and what seems to be different about these people? What varies? And so it was the things that varied that drew my attention.
And since we're not going into it with a question, it's what's relevant.
Right.
Yeah, it took looking at a couple of different player cards there for me to understand everything that I wanted to record. To the point, what was very.
The other part that really jumped out at me was if we look at the Tinker plots, I'm guessing it's Tinker plot. What is it on the right hand side? Workbook 1 with the multiple tables, because I think that is a different approach, very SQL-like, very relational database-like, to be thinking about multiple tables as opposed to a Hadley-Wickham tight rectangular one observation.
That's actually CODAP, Nick.
It's CODAP. Actually, that was my table. And the first thing I thought when I looked at all this stuff is I thought, well, if I'm going to be analyzing this data, there might be some interesting patterns here. And how might I want to group it? And the one thing that was easy for me to see that there were groups. Well, there's football players and soccer players, or and one who doesn't have one, which again that sort of threw me off a little bit. I was thinking forward to if I'm going to be doing some comparative analysis or want to make some claims about football players or soccer players. But that's how I would.
So Dan, did you enter the data in a hierarchical form, or did you enter it as rows and columns and then transformed it to be hierarchical?
Well, to be honest, the simpler thing was for me to take the comma-separated values and import it and then adjust the hierarchy in CODAP, because I'm able to do that very easily in CODAP.
But you could have entered it hierarchically.
I could have entered it hierarchically. And I was clearly thinking like I wanted to have it in this structure. I just had a convenient import of a flat table version first. And just dragged one of the columns over to make the hierarchy. The relevance question is also kind of interesting. I heard earlier, and also even the word modeling that was brought up earlier, because I do a lot of modeling, but from a systems modeling perspective. And one of the things that you think about is what are the boundaries of the system? What are the variables you want to include? And I think it's very similar in terms of thinking about a data model when you're presented with a bunch of information and how you're going to organize it.
Just a thought. I don't think I use this at all, but one contrast between the traffic scheme that we used and this one is that by putting the things individually on cards, you've kind of already created a case structure that I can then follow. And an alternative would be to put these characters in one sheet on the real world and with the information surrounding them.
Mm-hmm.
Where then I've got to sort of think about, well, what unit?
Yeah, and there could be two fields, one for soccer and one for football, and then Dan's grouping would have been
I like that.
hierarchy.
Yep.
Yeah, I mean, one of the other things I think in the car set is there were also more things that crossed across the potential ways you could structure the cases, whether they're headed east or west, or whether, anyway, I felt like there were more potential top-level hierarchies if I wanted to decide how to group them. So I had to think more about that data set.
And in the traffic one is also a lot of redundancy once you start to put things into a single table, and a huge potential to kind of save, space if you have multiple tables.
Yeah.
By thinking about it hierarchically, you're also, I think, interpreting which data is categorical and which is more on continuous nature. What are the attributes that you can group by that are categorical nature? Which is an interesting data move for the habit of mind, I think.
That's interesting to me, because I was wondering, in fact, if merging categorical numerical might make it harder for people, but what you're suggesting is that might actually make it easier to get a grasp on things. And what people have been saying about seeking out groups and, it sounds like people are employing some sort of clustering algorithm in their mind to kind of see, how do we get a handle on this?
I think that's natural. I think students also presented with data trying to group it in some way, make some sense of it.
Mm-hmm.
So did the missing values throw anything off? Did that require a different way of thinking or anything? We've never given missing values to our students, by the way. This is something I'm trying out on you.
Was that deliberate that did you talk about it, the possibility of giving them?
Well, this is the day one exercise when we do this, or it's week one. And so the week one exercise by design focuses on just a few things. They meet missing values later.
Mm-hmm.
And I did it to prepare us for activity number 2 as a segue. But I also was really curious about what would happen and should we do it in the first week.
So part of it is familiarity with the tool that you're using.
Mm-hmm.
So I know that CODAP is perfectly happy to have empty values for missing values, whereas Dan decided that he should put NAs in there.
Mm-hmm.
But I know that the NAs will be irritating later on.
Yeah, it was not so much as a conscious decision to include them as a lazy decision to remove them. But I did also, one of the things that I wonder about when I see different data sets, some of them have missing data, like there's literally an empty cell, and then some of them have, this is a value that represents, it's not measured or it's unknown or something. And I think that can actually sometimes affect how you're thinking about the data set. Whether people actually did people just forget to put something in here, or was it's deliberate that there's not something here now?
Right.
Did anybody record that the heights were in inches and the age was in years and the weight was in pounds?
Yes, I did. I was aware that I'm still trying to figure out the difference between a habit of mind and a data move. I realized that I made a decision to identify variables, and that feels like a habit of mind, but it certainly was also a move. I looked at one image to identify the variables and made a list, and then checked another image to see whether I had them all, and then decided to create a data table I was aware of thinking about in what order to put the columns. I hadn't yet noticed or thought about hierarchy. So I was sort of putting something at the far left as an ID type variable. I started to enter the data and then realized there were measurement in units, so I put them in the variable name column headings. And so there were, sort of becoming aware of having a goal to do something and then doing some things.
So that makes me think of another possible habit of mind.
Mm-hmm.
Asking the question, what's the metadata here?
Mm-hmm. Can you say more?
Well, I just wrote down the numbers, but I should come along afterwards and say, wait a minute, there's some information about these numbers, and that's what we mean. That's metadata.
Mm.
Such as the units, right?
What'd you say, Rob?
Such as the units when you said there's other information about these data.
About the numbers, yeah.
More than that too, about the units. It's, so at first I was wondering, are these completely random people or are they part of some group? And if they're part of some group in some way, I might think about grouping it a different way or approaching what kinds of claims I want to make about the data set in a certain way. So sort of the context of the data collection and thinking about the methods used to collect the data, those kinds of things I would consider metadata around the data set.
So students probably have conversations just like this one, Rob, is that right?
Yeah, so, yeah. And I have to say, I haven't worked with students with this. I've been present in the room when teachers have worked on this, and they don't ask about the data collection. I mean, that's never come up. I'm not saying it's a great thing to ask, but that's not what comes up.
Do they dive right into the conjecture, hypothesis land, or?
No, they so they work about trying to, they go to a table. I mean, they try to put it to a table or some sort of structure of that kind.
I see.
They are not thinking too much about the notion of the metadata doesn't come up, except some of them will put units in the variable name and some of them will put units in the case value. So as an attribute value.
Well, that's, and assuming you give them the same instructions you gave us, that's a real, am I thinking about entering these data and then doing analyses on them? Or am I just thinking, hey, see what I can find of interest? And if you told me the latter, I might not have created the structure I created.
Yeah. Well, and I think, in our context, we are not trying to send a lesson that says there's a right way and a wrong way. We're trying to send a lesson that there are many different ways. Some may be better or worse. Your software may have one way it accepts, so we have to spend some time understanding how that way differs from your way.
But without knowing the kind of what I'm going to do with it,
yeah,
you can't even decide what's better or worse.
Right. Exactly. Yeah.
So that only comes later, and I don't know how I feel about the task when that's.
Yeah. Well, I mean, I understand what you're saying. I think from our point of view, as long as they recognize that the structure isn't preordained, that they recognize. I mean, so one of the other notions here is that the same data can have different structures. So you might do a different analysis that requires you to go to that match, like that matched pair study. As long as you understand that that's something that has to be done, that it's not going to happen automatically. So I think that job is kind of done for, I mean, that's one thing this is meant to raise, is those questions about what what should the structure be. I would like, I mean, I am curious about what we're going to try this with. It's a little late this year for us, but to try it with the missing data, because like I'm wondering whether students will leave something blank for the missing data, whether they'll try to fill something in thinking it's a riddle that they're meant to know what's missing, or whether it'll signal to them, well, this attribute is an important name is missing, so it must be signaling it's not an important attribute. I'll take it off. I'm really curious to see how they handle that. So if any of you have the opportunity to try it. So what I'd like to propose before we move on to the next activity is I've tried to take some notes and organize things, as you can see under data moves and habits and conceptual understandings. Take a moment to look at that, and if you want to move something, to add a note by, let's say, you feel this should be somewhere else, just go down here to the notes and type where you want it to be moved to. And that way I'll understand, about how many people believe in moving it. Or if you want to just type in something in a new column, go ahead and type that in. But before we move on, I just think it'd be nice to see if we had, and actually, I guess, I'll tell you, we can leave this up here for quite a long time, and any of us can come back later and add or subtract from it.
Absolutely.
What do you mean about putting it down in the notes? You mean in the chat?
In the Padlet page.
In the notes.
Yeah, so if you double click on it, it has the ability to take notes.
I don't think we can double click on your post.
Oh, really?
I've been unable to do that.
Okay.
You can only edit the posts that you create, except for Rob. I think Rob has editing. The creator of the Padlet probably has grand poobah editing.
Oh, I see how that works. Well, then in that case, let's do this. If you want to move something, instead of moving it, just create it in a new column.
Well, I was thinking about look for groups. That seems like a habit.
There's a capability of connect to post. What does that do?
That lets you draw an arrow from one to another.
Oh, okay.
Oh.
So this arrow up here is a result of a connect. Up on the left there. I'm pointing as if you can see my screen, and I realize I'm not sharing it anymore. But
there, I drew an arrow from look for groups to data habits.
Ah, that's a good idea. Okay.
I just wanted to say, I'm still thinking about what Cliff was talking about, that the purpose really makes a huge difference. Because if you said that the purpose is to have a discussion about which people choose which sport, I don't think I would have thought of a table at all, and I would have only looked at some of the data. I would have ignored the names and places probably, although that might enter in to some extent. But well, maybe I wouldn't ignore because soccer is more in some countries than others. But, I would be focusing perhaps on their weight and height or, something else like that.
Yes, yeah, so agreed. I mean, if and Bill, you mentioned this briefly too, if you are approaching these observations with a particular question in mind, it might change the way that you organize or what you pay attention to.
Yeah, exactly.
What does seek variation mean?
Well, so I wrote that in response to what Holly Lynn said about how she was spending a time trying to decide what to record, and she thought, well, I'd look for things that are varying. So the number of eyes doesn't vary, so I'm not recording that.
have to unmute myself, sorry. So maybe it's not seeking variation, but it's, it's seeking to understand variation.
As a conceptual understanding or as a?
I think it's,
I mean, because understand variation or acknowledge variation is a primary statistical concept.
Right. But I think the habit is looking for things that vary or that differ.
Yeah.
Would that be in the bigger context of looking for patterns? It might be patterns of things that are similar, or patterns of, or anti-patterns where there's variations in things that you're not seeing patterns for.
Well, so say a little more about that. I mean, because like if I were told, if I were doing this task and someone said, well, to help you, you should be looking for patterns, then I would think that I had to somehow analyze the data, or maybe I know too much. I mean, maybe that's why I think that. But I would be thinking, oh, maybe I need to put these in order of the tallest to the shortest or something.
Right.
Go ahead, Dan. Sorry.
I was going to say, I mean, I feel like it is kind of natural to start to look to make sense of something by looking for similarities and differences between them. I'm a former chemistry teacher, and we often, we did cards like this with the elements of the periodic table, right? So how would you organize these? What would you start to look for? And so they start to look for patterns in the organization. I started asking myself those same questions. I was making the hierarchical table. Do I organize it by sport? Do I think, there's height aspects that I should be organizing by? Do I break these into quartiles and according to height or weight and then group them that way? I was really looking for some way to make sense of it, as opposed to it's just a random set of numbers and images.
Mm-hmm. And I think maybe describing it as similarities and differences, I think speaks more to what you were actually doing rather than just calling it patterns. Because I think sometimes the word patterns evokes looking for a pattern that has a predictive aspect to it.
Yes, yeah.
So is this discussion that we're having, is there an aspect of this that would carry over to the classroom? I can imagine the question after they've recorded the data, well, how did you go about this? And that would lead to some of these comments. Is that useful for students to be made aware or to reflect on their own process?
Yes, always.
Yeah, I guess I mean I could say that for us, and again I acknowledge I haven't been in the classrooms and seen this happening, but from what I hear from the teachers, they have found this a helpful thing to refer back to when the students start to see data in different shapes and things, to understand that you went through that process, and it helps them talk about what a case is. So it helps, if nothing else, it establishes some vocabulary.
Mm-hmm. Yeah, good.
Let's go to activity 2, because this is a new one I'm trying out on you. We actually do this with the teachers too, but in a much simple form. So if you go to DSET activity 2, I'm going to share my screen for a moment. I hope. Is it shared? No. Okay. Share screen. All right. So do you see DSET Gould activity 2?
Yeah, could you show us the tiny URL?
Yes, I could.
Talia will post this in chat for us.
Okay.
That won't help me.
It's in the Google Doc too. That
Oh.
has all the links and things.
Oh, I don't have the Google Doc.
There it is.
Oh, good for you.
So what you see over here is if you click on it, we'll download a data set for you that has some of the data that you just saw, but more of it. Not a whole lot more. And your goal is to, let's see if I can. No, it's going to do this to me. Okay. So your goal in this case is to come up with a list of rules. You can see that players are classified by their league, which is the same as their sport. That's either football or soccer. This is U.S. men's national team, I guess. I don't know. To come up with some rules that could determine how to tell a person whether someone was in, if you didn't know which league they were in, how to determine what league they were in. So what you need to do is write down a few rules that would help someone do that. So there are many different ways of going about this. You may or may not choose to use software, but I think I'll give us all 5 or 10 minutes to work on this, and you can interrupt and talk about, it would be, I think, helpful if you talked about what you were doing as you were doing it. I mentioned what you were trying and what thoughts or questions you had as they came up, either through the chat line or by typing into the Padlet. Can I say anything more about that for anyone?
Yes, you could repeat the whole thing.
Uh-huh. So I'm happy to. When you click on this football training thing, it's going to download a file that looks like this. And what we want to do is imagine creating rules that, given the data, would let us predict which league a player belonged to. So can you write down 1 or 2 or 3 rules that say, if this and that or this, predict that, otherwise predict something else? And there are 2 predictions you want to give. NFL, so you want to predict either football or soccer, with apologies to those of you who are not in the United States or Australia, I guess. Yes, so that's helpful.
Do you want these things here, or should we keep them off of this page and just talk about?
No, here is great. Yeah, and you can put work down there or something, and we'll clean it up as we go. And the one thing I'll add is, if you want to peek into the future, you can click on this testing thing, and it'll download a new data set, and we're going to apply your rules to that new data set. Football testing down here.
So there's a league, but is there a sport?
League and sport are the same thing. So everyone who's in the NFL plays football. Everyone who plays football is in the NFL. And everyone who's in USMNT plays soccer, and everyone who plays soccer is USMNT. I spoke I was sloppy in my speaking. I mean, we're trying to predict league membership. I wasn't deliberately sloppy, by the way. I was sloppily sloppy. But if whoever typed league equals NFL, don't erase that, because I think that's a really important thing.
Can I just delete 2 of the players? Make my life.
Yeah. I know what you mean, Bill.
I think I'm going to let's let this go until 10:15, and then we'll regroup a bit and talk. And if part of regrouping means that people want more time, then that's what we'll do.
Do you want us to go ahead and write the rules in the Padlet?
Yes, please.
Okay.
I'll move this one up here.
Well, if it wasn't for those 2 data points, I'm stuck on that.
If leak equals USMNT, predict soccer. That's a good rule.
Who did that? Why didn't I think of that?
I did this activity with a large group of community college teachers, and we simplified it, gave them less data, but the same thing. And I actually was very clear and said, you will not know when you get your new data set what the league is. And yet this was still the plurality choice, was to use that variable to predict.
It's funny.
Yeah, I think it's a very natural thing to do. I've seen my own students do it too.
Well, those 2 are just playing the wrong sport.
Maybe there is an error in the data entry.
You're thinking like a high school counselor now.
Well, if you look at it from the age perspective, maybe they're not playing the wrong sport.
I found the age even more mystifying.
I mean, I find it odd that it came out the way it is, but it looks like there's some difference between it.
I don't understand that, Dan.
I intuitively didn't expect that you'd have older NFL players.
Oh, I was talking about that with a friend recently about that. Apparently there's a good reason. There's some reasons for that, just because of the nature of the way that football is played. Like, it doesn't wear on the body as much or something.
Yeah, it wears on the brain.
The brain doesn't know it's getting older anymore.
Right.
The longer you're in, the less you feel.
It also depends on the position and stuff too. Like, there's some football players who can play their position a really long time just because it's so big of a toll.
Yeah, well, let's what would people like to do now? Any comments about this process before we go to round 2, which is to try to apply your rules to some actual data? Okay, let's go to round 2. So if you click on football testing, let me share my screen quickly, now that I know how. If you click here on football testing, it'll download a new data set. And it's not looking for me, but it will for you. Oh, here it goes. And there. And you can apply your rules to this data. And if you'd like, you can amend your rules and tell us, so here's what this new data set will look like. And you may want to then amend your rules to see if you can predict what these outcomes are.
Well, that rule about league is not going to work on this.
Yeah.
It's asking us to predict which player it is, too?
No, just which league.
Okay.
Which league? Okay.
But that's an interesting question, I mean, to think about. I mean, why do we ask you to predict the league and not the player's name? I guess if we were Amazon or something, we would consider it fair game to predict the name.
Unless that were a violation of our privacy agreement.
Uh-huh.
Hey, Rob, I'm jumping in a little late. I'm Jennifer from Pittsburgh. Hello, I go by Aitkins. I'm a member of the Fluency Project cohort, and someone from NextMap looped me in. Where would I find the Padlet? I'm just trying to find the data set.
Tell you what, I'm going to share the screen again, and you'll see the URL.
Wonderful. Okay. Thank you so much.
Do you see it right here?
I do. One moment. I'm going to get really close. You'll see up my nose in a second.
One question. Are these 5 a subset of the original data set, or we're applying our rules to predict where these new people would be?
These are new people. Drawn from the same population as the original subset.
And Rob, I missed this, but am I just supposed to apply my rules and see what happens, or am I supposed to kind of, if I don't like quite the fit, I can fudge? Which is it?
Apply your rules to see what happens. Although
Okay.
I will tell you right now, I'm not going to tell you, well, maybe I will, but a manager might not tell you whether your rules work or not,
okay.
but apply them. And many people, when they look at that, will amend their rules, but you may or may not. I mean, you may be happy with it.
Well, I can't amend them until I get feedback anyway. Or I shouldn't.
I saw Nicholas's chin as one of the rules. I wasn't quite sure what to do with that.
I like these 3 CODAP tables. They all have the same prediction.
Mm-hmm.
So Cliff, how did you apply your rules?
Well, they were very easy to apply.
Yeah, but they don't always predict the same thing.
No, they don't, but I went with the stronger rule.
I see.
There was a third rule that I just realized, that it says, you know, if you get contradictory information, go with
the weight rule.
Oh, I can't remember which was stronger.
Wait.
What do you mean by stronger?
Well, if I get contradictory evidence from applying the two rules, go with the rule that had less overlap between distributions.
Hmm.
The one with the two variable axes kind of strikes me as interesting, with age on the vertical axis and weight in pounds on the horizontal.
Uh-huh.
I'm not sure who did that one, but it's really beautiful to me. Like, makes sense to kind of put the two variables together in that way.
I am also making the weight and height one a little bit bigger.
It would have been nice for that one with the bivariate. Again, obviously, there was some kind of interaction, but there's not. It's still those two that just don't fit particularly well. Though we do have that additional information of the older age of the NFL, which we talked about a few minutes ago.
Yes.
Yeah, I think you need a data set that lets you go a little bit further than just using weight.
What say about?
Well, it's very frustrating not to find two rules I can use together.
I see.
Yeah.
I guess what Nick was saying with there's no interaction, so I kind of hit a dead end.
Couldn't you possibly use the weight and the height to get a new rule together?
No.
Why not? Right, you could still say, you could find a linear line there that separated the two.
Mm.
I don't see one.
Yeah, it's so hard for me to, let's see.
I'm going to share what I did with that.
So what I also think is really interesting is that the two cases are from the original data set were things that we were really hung up on, that we had to, we wanted to all perfectly account for them. So we wanted a deterministic rule that would give me a 100% prediction. But in the data world, we want our students to be, there's places where we want 100% prediction. But we also want to be able to make predictions just with a level of confidence that my prediction will capture this much with error.
So is what you're saying that the frustration comes not from the lack of an interaction, but because of the inability to create perfect discrimination?
I think so. I think what's hanging, I'm suggesting that perhaps what is hanging folks up is that they want to, they see this interaction going on, but they want to create a rule that is perfectly predictive. Where I kind of disengaged a while ago because I was like, okay, well, I have a rule that predicts everything but two cases. I'm okay with that.
Yeah, so, but actually my frustration was not that I couldn't come up with a perfect rule. It was that I thought that I was dead-ended at using weight, that there was nowhere further to go.
Yeah, so I made this exact same graph that did you make this one, Bill, that you just put up?
Are you pointing at something, Dan?
The height versus weight with the regression line on it, or the line on it?
Yeah.
So I made it without the line, and I was thinking, okay, well, are there areas where, it's pretty clear that I could circle the lower left or the top right, and if my data fell in that cluster, I would feel pretty good saying I've got at least two variables that are helping me make that decision.
But when you say cluster, the two oddballs are in the NFL cluster.
No, I mean a subset of those where there isn't overlap. I wish I could.
But Bill, let me look at this one. I mean, like, there's only one there, right? So you could draw a line through here, like this one, that cuts your error rate down in half.
Yeah, right. Yeah. I didn't realize I could do that. So, so my frustration was from a lack of thinking.
Ah.
I was thinking here, maybe up here.
Oh, wow, what tools people have.
So I was, that's where I was like, well, if my data fell in here, I want for these two variables, I'd feel pretty confident.
But you could do without the height variable. The weight variable is enough.
Mm-hmm. Well, anyone care to start thinking about moves, habits, and concepts, or?
This brings up a point that I think that I've come to think is really important in tasks we give to students, and that is exploring what we mean by success and prediction.
Mm-hmm.
And I think when I look back at a lot of tasks I gave students, I either left it unclear or I really set them up to kind of think that they're only successful if they nail it.
Mm.
And in statistics, that's, as Holly Lynn pointed out, that's never our expectation, right? We have some sense of wanting to get a certain percentage or within certain brackets. And I think if we give students that sense right off, they might approach the task and think about it differently. Here's what I mean by success. I mean, who would think I could predict whether you were a soccer player or football just from one or two variables? I mean, that's kind of absurd. And yet how quickly we're all hoping we can eliminate these two oddball cases. So we sort of got into a kind of non-statistical way of thinking, not very sophisticated anyway, way of thinking. And should we provide students with or help them explore what we might mean by success? What's good enough? How do we evaluate the quality of our model?
And what's
you saw that going on with the hurricane just this week, right? Where oh, the models got it wrong. Oh man, they came really close.
Yeah.
Right. So I mean, so what if we're asking for them to make a prediction and how, and a confidence to informally to be able to describe how confident you are in that prediction?
Well, I don't think the confidence quite captures it. That is, I can still make a point prediction and have confidence.
True.
And I'd rather get students predicting ranges, for example.
Right.
And then if I show them a value is within their range, they can feel like, I got it, success. Otherwise, they always fail if they think the expectation is that they get it perfect.
Right. No, I hear you. I completely agree.
Could lead also to the conversation about what's the stakes here, what's resting on the decision, what's our tolerance for type 1 errors, what's our tolerance for type 2 errors.
Rob, you've said you're not going to give us the labels, but if one implemented Cliff's original rule, what is the error rate on the test data?
I'm not going to give you the labels because I can't find them. I think when I created the data set, I just dropped them off, and I would have to go back and figure it out again. But I think it's I will turn this into a teaching moment and say what percent error do you think we made? To address Cliff's point somewhat too, is this has been an activity that's been a little frustrating for me, at least, because the way I envisioned this happening was that students would come up with competing two things. I mean, so the primary point of this exercise was to start to was to help develop the notion of an algorithm, and that they had to write rules down that someone else could carry out. So they had to be clear enough in their specification of rules for that to happen. And that part of it has succeeded. I mean, goes as well as anything goes in the classroom, I guess.
So when I do this soon, Rob, which I do plan to do, because I've always loved Cliff and Bill's traffic examples as a way of starting to get people thinking about this. I'm going to go to like men's and women's tennis and men's and women's golf, and see if I can get something where there is a gender difference, but there's also a sport difference. And I don't know if I find anything there, but to have it be one step more complicated.
It might be.
Start with this and move to something a little bit more complicated.
Yeah. So what I had hoped would happen was students would come up with different rules with different rates of success, and then we could have the discussion about which rule is better and why. But we've had these data. You know how these classroom things go. You iterate very slowly sometimes, and so this is a second iteration. The first iteration, it was too easy to make a classification that had only one mistake, and everyone got to that decision. And now, so we've added some complexity to the data, but it's still, I think, maybe not complex enough. But if it gets too much more complex, students kind of run out of rules quickly. I mean, they even though this is near the fourth unit, they don't necessarily go to bivariate thinking. The teacher has to kind of bring that happening. What I guess we've seen happen is one student will focus, or one group will focus on weight and one on height, and the teacher will have to do something like, well, what if we put those ideas together, sort of thing, to get those. I guess what I'm a long-winded way of saying is, from what we've seen so far, students tend to focus on univariate reasoning and their rules. And I've actually seen teachers do that too. They'll just come up with one rule. And I'm not sure if that's because we tend to think univariately, or if it's just because in these data, that one rule works pretty good.
Mm-hmm.
Although they do get frustrated that it doesn't work perfectly. I mean, and they think there's something they're missing.
By the way, just another rule I noticed, that you in your test data set, you've got 29 NFL players and 21. So there's actually a base rate suggesting maybe I've got more football players. So
yeah, that might be another rule.
If you give me a case, predict NFL.
Yeah. Yeah.
Imbalanced classes.
Or if you're in the middle, Cliff, flip an unfair coin with that probability.
Right.
Well, so a question I guess I have for the group too is, what's been lurking in the background of this is our use of technology. And so I see, just a quick glance, maybe 3 different technologies employed here. How well did you need to know your technology to do this? And I'll give a personal example. As always, when I started to do this in RStudio, I had to look up, how do I get different colors on that graph? So that's something as a data move that kind of held me back. Was I could visualize in my mind that I wanted height and weight with the teams in different, or the leagues in different colors, but I couldn't implement that move until I looked it up. So are there
a data move, Rob?
That's my question. Is that a data move? Because everyone made graphs here.
I think that is a good data move. What technology tools can help me to visualize this?
Yeah, so yeah.
I think that creating 3-dimensional graphs, kind of bringing 3 dimensions of data together, is not something that's been part of traditional statistics education, unfortunately. Yeah. But I think it's a really important thing for people to be able to do, and to have it be very, very straightforward for them and natural to start to explore in those ways.
By the way, just on that, I've always been amazed at how young of students, when you give them data like this, want to get 3 or 4 variables on a graph represented. So it's not an idea beyond the reach of very young students to want to be able to graph and see multiple variables.
Yeah, I completely agree. They just have to know the tool can do it for them.
Right.
in some accessible way.
But they'll also try and put them on sometimes in ways that don't make a lot of sense. In graphs that can't possibly show those things.
Yeah, and not to dip too far into controversy here, but I mean, I think that's been one challenge we faced with using RStudio, is students often and always have questions about 3 or 4 dimensions, and those questions get cut off because even the teacher sometimes can't figure out how to do the visualization for them.
Mm-hmm.
And I don't know what one approach we've been taking is to try and give them a stronger toolkit, but you know, I think that's definitely a limitation.
You should look at CODAP.
I know.
And that really is the design philosophy that you talked about with the Mosaic package in R.
Yes.
Rob, because it's really critical to kind of have fewer things that people can start to use in a more powerful way. And CODAP certainly does that, and that's what we've tried to do in Mosaic.
Right. Yeah. So that is the goal, but nonetheless, it is still a challenge, and I think it's a surmountable with the right preparation, but it's definitely a challenge. Well, so I think we're close to wrapping things up, but let's just take a moment to see if anyone would like to add any reflections to data moves, habits, concepts, move things around, create new connections or anything like that, and tell us about why they're doing it. Yeah, you know, for me, and Cliff, I mean, this question about do we use CODAP or not is a tough one because as this project began, it was meant to teach programming, which was equated with computational thinking. And I mean, since that time, I think we've broadened our knowledge. I've broadened my knowledge, and other people in the group, about what computational thinking might mean. But still, how much of that do we want to retain? I mean, that's the core question here is what is the minimal amount of computational thinking that lets them do these things, which I think are important things.
I was struck, Rob, that in one of your slides you had statistical thinking as a subset of computational thinking. And I don't think of them that way. I think of them as quite different.
I don't, that's what I've weaseled around by talking about what is computational thinking when we apply it to understanding data. Certainly I guess, yeah, maybe I would take that back. I will say if you look at the official definitions of computational thinking, they do include statistical thinking as a subset.
Huh.
Which is very frustrating to me, and now I'm doubly frustrated that I've made the same error. But I think if we're thinking about what thinking applies to data, all of statistical thinking is needed, and some of computational thinking is needed.
Mm-hmm.
So the question now is what is that additional bit of computational thinking that's needed?
So
one question I had regarding the course that you've set up, you know, students are using R, and you know, I'm not that familiar with R, so I don't know, but you know, for example, in setting up the visualization of height versus weight with the coloring on the dots, I mean, it seems like one could write a program that's like, if, you know, iterate through the data, if the data, you know, has this league, then add this color to the data point, right? So then you're doing computational thinking in order to generate the visualization you want. But is that what are you thinking of it in a different way?
Well, I'm going to stop sharing. That's a great question. I mean, if you're only, that's a great example, I think, of what computational thinking would be devoid of any statistical thinking. You know, so the exercise you designed would be just one purely to design an algorithm that would create a particular graph. I think what we're more interested in is students creating graphs to answer a statistical question, which is in this case, or a statistical problem, which in this case is how can I classify players based on these characteristics. And certainly some computational thinking is employed to create a graph, but at what level of computational knowledge do they have to actually get their hands dirty?
It's like describing the algorithm for, or the process of exploratory data analysis.
Mm-hmm. I mean, it looks more and more like what we mean by computational thinking depends a lot on the technology we're already using.
Yeah. So I just threw into the chat the line to print, to create the graph, and the line to kind of add in that label. And I think the other part that's really important to kind of for us to be thinking about is how do we actually structure this stuff so that a week later, 6 months later, someone goes back and can reproduce what they had actually done. I think it's really great to have interactive tools to let people explore, but then there needs to be some scaffolding or support, which could be actually done on the fly, that allows people to kind of get back to where they were and how things were put together. And so I think these kind of questions of tools and what we want to have both in terms of thinking and their ability to do things, there's lots of work out there.
Yeah, thank you.
So, Nick, to what extent does that come up in a pre-college classroom setting?
So the way I see it coming up most commonly pre-college, Bill, is thinking about project-based learning. We want students, even in pre-college, to have some exposure to the kind of the scientific method and a statistical analysis cycle. And then the question is, how do they actually do that in some way that's structured with scaffolding to let them kind of go through that and not have to be starting from scratch every time they do something.
And something else that I was thinking about as you were talking, as far as how you put in the mosaic code, Nick, I don't know if any of you have used Geometer Sketchpad long time ago, but you were able to, if you created a particular dynamic sketch, you could highlight all of those objects and create a script that would record all the different steps to create those geometric objects. And I'm wondering if in tools like CodeApp, if it would be useful to be able to select different things and extract out a script basically of what the steps that were used, the data moves that were used to produce that final object.
Well, the thing about Geometer Sketchpad is that it doesn't produce a record of what you did to create it. It just creates a script such that if you apply the script, you will get that thing.
No, yeah, you're absolutely right. You're absolutely right. Yes.
And
so it cleans it up, basically.
Yeah.
Right. Right.
And I mean, it would be almost trivial for CodeApp to print out the undo history, the things that you actually do, but I question whether that would be actually helpful to the student, to the learner.
No, but maybe having something more technical so that, I mean, if we want students to also be learning kind of this computational thinking aspect of it, if there were more technical scripts, I don't know, just thinking aloud.
I had a question for Rob. This is sort of along the lines of my earlier question, but I'm in CodeApp and I create one plot and then I decide to create another plot, and then I'm going to select some data in that plot, which of course highlights that data in my corresponding visualization. And I use that to then filter the data in my other visualization, because I want, all the folks who have a certain weight but below a certain age, for example. Am I doing computational thinking because I'm dragging and selecting things and filtering in that way? I mean, I could write code to do the same thing, but I'm wondering, would it be considered computational thinking when it's done in a non-code-based format?
Well, yeah, I wish I had a good answer for that. I mean, I think I have colleagues who would say definitely not, but I'm not so sure myself. I guess, one answer would be you're not, because you're simply applying someone else's algorithms. Another reason for why it would not be is that it's not reproducible. Like, someone couldn't necessarily reproduce the steps you did. But I think, that's a great question for me. I mean, to me, it's right on the boundary. Is that computational thinking or is that statistical thinking?
Well, if you asked the person after they had done this thing to write it down, what they did in a way that someone else could reproduce it,
yeah,
then they would have written a script, and that would qualify.
Yeah, that's very true.
But if the machine writes the script for you, I don't think you're doing the computational thinking.
Right.
Well, you might have still formulated an algorithm in your head in order to execute it, even if you didn't articulate it necessarily.
Well, I think Dan is basing his selection on what he sees and adjusting it to capture just the points in his selection that he wants. And that's not an algorithm. Well, it is kind of.
It's hidden. The algorithm is hidden in his judgment about what he sees.
Yeah.
Well, and then the question is, to what extent does making that algorithm explicit help students succeed in tasks like this?
I think
if he had written a formula that comprised that reproduced what he saw, that would be
right. Which often it would almost be impossible to do, right?
Sometimes, but sometimes I'm like, okay, I want to eliminate all the people below 180. Now I can drag a space, so I'm looking at it visually. I could create a new column that says, only put the value of weight here if the value is above 180, and then I have a new attribute. It's all the things that are above 180. In both cases, I don't feel like I've actually done different thinking. I feel like one took more work for me to do, but the end result resulted from this idea of I want to filter out this group here, and sometimes that could be, I guess, purely visual, although I'm often looking at the numbers underneath. But I could also put it as a really simple filter in Coda.
So I have a related question. I often think as a prime example of the need for computational thinking is with the cleaning of the data. So I've got an attribute that's just one attribute that's dirty somehow, and I want to write an algorithm or a formula or something that produces a new attribute with all of the clean values in it. And in a spreadsheet or in CodeApp, we can do that with a formula. If we're using R, we might need to have a loop in there. I don't know. And so when there's a loop, I know that's computational thinking. But if I'm just writing a formula that implicitly loops through the data, I think of that as computational thinking.
Well, I guess I think of computational thinking in this activity is that ultimately to make predictions you need a rule. We're not saying that these 2 points tell me what your prediction is. We're saying come up with a rule that will classify future points. So to me, that's an aspect of computational thinking. And now you may apply other aspects to that of data moves and habits and statistical thinking to help you implement that and determine that algorithm. I think we're out of time. Is that true, Natalia? Have we?
Yes, yeah. 10 to the hour.
So let me just wrap up by saying, thank you. I hope you haven't felt a sense of completion, because I haven't felt a sense of completion. But I think particularly this prediction activity is something that's well within the grasp of high school students. But I think there's just so much more to think about. What do they need to know, and how do we scaffold this to make it accessible so that they're learning the things we want them to learn? So I thank you all for sharing your thoughts on this. And these Padlets will stay active, so if you want to go and add things to them later, feel free, and we can base future correspondences on them.
Well, I loved that you set it up so that we had problems to solve and talk to each other about them, and made us reflect on what we were doing at the same time.
Yeah, those were terrific activities. I appreciate the chance to dive into them. And
thank you.
Very interactive webinar. Thanks.
Thank you.
All right. Is there an official wrap-up, Natalia, or we just all say goodbye?
Oh,
we get to tell people when the next one is.
Let me share when the next webinar is. So 1 second, please. I just need to share my screen and pull up the right icon.
I think it's Amelia.
Amelia is next, October 10th.
And in the meantime, I'll look up the missing football scores and let you know what the true classifications are.
Yep, absolutely. So please do sign up for Amelia's session on October 10th. You can do so at concord.org/meetup. And also please be sure to stay connected with us on Twitter. Thank you for the tweets, by the way. I saw that we had a couple during the webinar. Please use the hashtag DataSciEd to share any additional questions or resources, or if you have an updated Padlet or more thoughts you'd like to share, we'll be happy to respond to you. And I look forward to seeing you all October 10th for Amelia.
Thanks, Rob.
Thank you.
Let's see everybody.
Bye.
Thanks. Bye.
Bye-bye.
Bye.